Okay, so I'm Fred. I'll be talking about Salmon, which is a volunteer proxy-based system for internet censorship circumvention. All right. So to start off, let me just really quickly talk about the problem we're dealing with and the general approach we're going to take. So we're trying to provide internet access to people who are living under censorship, and we're going to do it by trying to give them just direct VPN servers to connect through. And so the way the censor is going to try to fight that is to discover those servers and block them. So this isn't something like decoy routing or domain fronting where we're sort of just doing something that the censor just can't deal with. Rather, we're doing something that the censor totally could block. We're just trying to hide it from them, right? So it's the most important thing to the most important part of the threat model that we should keep in mind when we're talking about this is that we're assuming for what I'm going to be talking about in this presentation. So there's more in the paper that goes more into the real world stuff, but for the algorithm stuff I'm going to be talking about here, we're assuming that the censor can only block our proxy servers if we give them to them. So we have this distribution mechanism, which is what we're evaluating, and the censor can only block our servers if we have mistakenly, intentionally handed them out to them. Now, in the real world, of course, is traffic fingerprinting, like cookies that they might, other things they could do to maybe discover addresses. We do address that a bit in the paper, so don't think I'm just glossing over it. But for what I'm talking about here, we're assuming that this is just it's basically just a game we're playing with the censor of, how are they going to behave in our system, and does that let them block servers? All right. So with that, before we go into the theoretical algorithm stuff, let me just talk at least a little bit about the system that we've actually designed and deployed. So as I said, it's VPN server based. So the entire thing revolves around, we have a network of people volunteering to run VPN servers, similarly to Tor, people volunteering to run relay servers, and maybe hidden bridges and exit nodes and stuff. And we're distributing these out to users. And that is the distribution is what's important here. So if we just give the whole list of servers out to anyone who asks for it, obviously the server can come along, ask for the whole list, and block all of the servers. So what we want to do is hand out just a few servers at a time and keep track of what is happening when we give what servers to whom. All right. So the entity doing all of this logic, tracking the volunteer servers, tracking the users, and giving servers to users, it's just a centralized server. Again, this is something that would be a good target for the censor to block. So we need some way for the users to get there in the first place. We just have built into our client, we have machinery for the client's requests to get tunneled through an encrypted email provider like Gmail or something, or any other encrypted provider that isn't blocked in the user's country, because Gmail is not necessarily a good choice for that. All right. Now, the last thing I should say before we move on to the actual algorithm stuff is the most important for this talk of this real world stuff, which is that we need some sort of barrier to entry, because we can talk about these interesting algorithms for sussing out who's a censor agent and who's not, but all of that falls apart completely if the censor can just insert as many fake identities as it wants into the system, because then they can have 10 times as many fake users as there are real users. And there's no way that, no matter how smart your algorithm is, you're going to get overwhelmed. So we try to establish this foundation for our system, this barrier to entry to keep the fake identities to a minimum at least, by requiring either that the user presents us with a plausible looking Facebook account, or that they get recommended by a user already in our system whom we already trust. And I'm going to be talking pretty soon about what trust means to us. So for the Facebook account checking, what we're doing right now is we just require the account to have been created before a certain date so that the censor can't just come along and make a bunch of Facebook accounts, and also to have some posts on it. So that's a pretty simple approach. You could imagine much more sophisticated things like some sort of machine learning to say, oh, does this look like a good page or not? Those are things that could be added to basically strengthen the system. Okay, so with all of that, let me now move on to the actual, the algorithm, the distribution algorithm that is the center of this system. All right, so this distribution algorithm comprises three components. There's suspicion, trust, and recommendation grouping. So the suspicion is kind of suspicion is the foundation of everything, and this is the logic of banning people from our system who we suspect might be actually working for the censor, trying to discover servers. So basically what we're going to say is, all right, we're going to keep track of you. We're going to keep track of what servers we gave you, and if your server gets blocked, we're like, all right, you're not the only person on that server. There are also these other people. So all these people on this blocked server, we suspect, maybe it was you. And after any given user has witnessed enough of these server blocks, had servers blocked while they were assigned to them, we're eventually going to say, all right, there's a good chance you're an agent of the censor, so we're going to ban you from the system. You're gone. You're never coming back. So this clearly, there's collateral damage going on. We end up banning some fraction of our users. That's bad, obviously. It's inevitable for this approach. But on the bright side, we're also permanently banning any agents of the censor, which means that if we are managing to limit the censor's identity creation so that they can't just keep inserting as many identities as they want forever, if they have some finite supply of identities, even though they get some of our users banned, they're also eventually going to just get wiped out of the system and the attack is over. So that's good. Okay, so that's the suspicion component. The thing that really, the thing that makes Salmon effective and makes it effective is this trust level logic. This is actually, just as a fun aside, this is what the system's named after. We call it Salmon because we have these trust levels of, all right, so first I should say what they are, then I'll say why we named it that. All right, so we have this idea of trust that's basically, if you have been using our system for a while and the servers we assigned you have not been getting blocked, then we're going to say, all right, we trust that you look like you're not causing trouble so far, so we're going to trust you more and more as time goes on. And we quantify that as discrete trust levels. So you after you've been in the system for a while without blocking your servers, you'll go up a level, up a level, up a level. All right. And so we call it Salmon because it's like a salmon sort of hopping up levels in a waterfall and maybe falling back down if servers get blocked. All right. And finally, we also, as I said earlier, you can get into the system if someone who's highly trusted recommends you. This would be an issue if the censor just is patient enough to get a group of its users up to the top level and then start recommending people in, and you can get exponential growth of their network that way, which would just completely defeat us. So to stop that, we group people together with the people they recommend or who recommended them. So if you look at all of our users, you end up with a forest with links being recommendations, and so each tree in this forest will always be on the same server. So if you have a tree of a bunch of censor agents who recommended each other, they're just going to always be on the same server, and so they're spending all of their, they're all going to get banned just to block a couple of servers. And on the other side of that coin, if you have a bunch of good users, they're going to be on a server together, and it's just them on that server, so they're never going to get their server blocked. So that's good. All right, so these trust levels are, you get promoted with exponential wait times. So it takes 2 days to get to first level, then 4 days, et cetera. So to get from the very entry level all the way to the top is going to take 128 days. So aside from the fact that it just gives you a nice long wait time to get all the way to the top, the exponential, the specific distribution means that even if your user base was growing exponentially, you're still going to get a nice even spread among the trust levels of your users, which is important because, I mean, if you had everyone the same trust level, obviously it's like you just didn't have trust levels, right? So this is just want to quickly show, this is what happens, this is why trust levels are beneficial. So if we just take the whole Salmon design and disable them, you basically get double or triple the number of innocent users who get banned from the system or cut off from servers. And with them, it does much better. 1 minute. Okay. All right. Skip this. Okay. And all right, so that was just comparing the performance of the system to a crippled version of itself. So I should also point out that this is a comparison to the previous best work, R-Bridge, which is effectively it's effectively the suspicion component of Salmon alone. It kind of goes about it a different way, but it ends up being the same sort of philosophy. So we also do a good deal better than that. And finally, this recommendation grouping, just to demonstrate how bad it would be if we weren't doing it. So on the left, this is a scenario where the censor has been patient and let a bunch of its agents get up to the level, the top level, where they're able to recommend people. Then each identity brings a few more in. And so if we don't do this recommendation grouping, they're able to basically completely shut down the system. Whereas if we do have the grouping on, they do damage, but it's not really, there are still over half of the users with access. All right. Okay, so that's it. I'll take time. Time for questions? Okay, thanks. So yeah.